on Monday we started talking about discrete variables. What is a discrete variable? Give me like kid words. What does that actually mean?
Gaps.
Say again?
Gaps.
Gaps.
Countable numbers.
There's countable numbers. There will be gaps in between numbers. Okay, cool. Sorry, I was like caps. Excuse me.
That's pretty cap.
Yeah. So there's gaps, and we're talking about countable numbers. So what is it going to look like? You're probably going to see this in the form of a table. Okay. And so with that table, you'll have a certain amount of values, and then you'll have those corresponding probabilities. That's what your discrete is going to look like. So it's going to be like 0, 1, 2, 3, 4, and then it'll have the probability for that. Okay. All right, continuous is going to look like a normal distribution curve. Okay, so you'll have some value x, and you'll be able to compare it to the mean. And then they probably might give you the standard deviation.
My tutor took everything out and put it and organized in my folder, so I can't find anything.
Well, hey, the worksheet that you need is up on the table at the front. All right, for binomial, we talked about bins. So we talked about binary, whether or not it was successful or not, independent, the fixed number of trials, and then the same probability. Okay. And this is where we're going to have N and P, right? Geometric, we talked about the acronym BITS. So the only difference between these two is this is until a success. Okay. It doesn't have a fixed number of trials. Hopefully all of that's coming back. Okay, cool. All right, now what does the mean look like for these? The mean for a discrete value is going to be what we call the expected value. So here's the formula for expected value. Remember, it's your value times your probability, add all of those up. Okay. So again, for discrete, we oftentimes use expected value kind of interchangeably. If you are asking about a continuous mean, they oftentimes have to give it to you. So we're going to say it's given to us. Okay. For binomial, in order to find the mean, we're going to do N times P. So that means whatever your sample is times the probability that you expect to get.
And Z, wait, first one is Z. Oh, it's that sigma. I thought that was a Z for a second. I'm sorry. Is that times or an X?
So this is a sigma, the summation of X times P of X.
Okay.
And then for geometric, we have 1 over P. Okay, grab the paper up at the front. All right, so everybody good on that? We know how to find the mean for all 4 of these. Okay, standard deviation is where it gets a little weird. So we got little sigma is equal to the square root of X minus the mean squared times the probability. Remember that your calculator does this for you. Yeah, this is where you put it in menu, statistics, and use a one variable statistics, and it pulls it up. So you don't have to do this by hand. Remember, you use it for your calculator.
Okay.
Yeah, calculator come in clutch. For continuous, they normally give it to you, so it's going to be given. All right, for binomials, we have the square root of N times P times 1 minus P. Sorry, that's a little scratch. And then for geometric, kind of similar, the square root of 1 minus P divided by P. Okay. Okay, I'm gonna give you a second to catch up. Okay, so for discrete, when we talk about the probability, what you're gonna do is you're gonna use the values in the table. So remember with discrete, they'll have values across the top, then they'll have the probability at the bottom. You'll just use the probabilities at the bottom to help you kind of figure out whatever the question is. Continuous is you're going to find the area under the curve using your z-score formula. Okay, and then you would go to your table and find the area. For binomial, this is the crazy one. Remember, we want to use our calculator for this one. This is the n choose k probability of successes with the probability of failure. And then for geometric, we did the probability of failure times the probability of success. Bless you, bless you. Is to be able to use your calculator. That's the fastest way to do this. So with the first one, discrete, remember, you're going to put your x values in list 1, then you're going to put the probability in list 2, and then you're doing one variable stats. Okay. For the continuous, you're going to use normal CDF. Okay. We didn't do it this way. We just kind of used the table, but this is kind of a shortcut. Normal CDF, you do your lower bound, upper bound, 0 and 1 for the mean and the standard deviation. That normalizes the curve. Okay, so this was back from like unit 2. You can use normal CDF in your calculator. You can put the lower bounds, upper bounds, etc. Yeah? Good. If they give you a mean and a standard deviation,
I forgot how to do.
you put whatever the mean and standard
I
deviation.
forgot how to figure out
Yeah.
the standard deviation on the calculator. Every time I try to type it in, it does not do it right.
Okay, let's take a look at one of the example problems in a second.
Okay.
All right. For binomial, you've got binomial PDF. And that's where you're going to put in PK. And then for binomial CDF, that's when, okay, so PDF is when you're trying to find an exact value. PDF is when you're trying to find if it's less than a specific value. So binomial CDF. Okay, CDF is less than a specific value. PDF is when it's exactly or precisely that number. Okay, yep.
We're trying to find like the probability that it's 5.
And then do 1 minus whatever that is. Now, if it's included like 4 or more, then yes. More than 4, then you would do 5. No? So if we want to say 4 or more, then we would do 4, right? Because it's including 4. So we would do 1 minus whatever the value is for that. Does that make sense? Okay. All right, and then the last one, geometric PDF. That's when we're trying to find the exact value. If we want to do less than that value or equal to that value, then we're going to do CDF. Okay, we okay?
Almost there.
Is that helpful?
Yeah.
Oh, good. Good, good, good. Okay, so she just asked a good question about the CDF versus PDF kind of thing. Remember, if we're going to get less than a value, I'm going to show you this example really quick. So this is back on the 6.6 notes. Back on 6.6 notes. When we did at most 3, okay, look at what we typed in for binomial CDF. We said n equals 5, p equals 0.25, and x equals 3. So at most 3. Okay, if I do 3 or more, I'm going to do when x is less than or equal to 2. Okay, so I'm hoping I didn't say that backwards when we were talking about it. So binomial CDF, n equals 5, p equals 0.25, and that would be equals 3, because we're saying at most 3. If we're saying 3 or more, we did 1 less than 3, and then 1 minus whatever that probability is. Okay? Good? Need a minute? Okay. Go ahead and take 5 minutes to get your life together. If you need to look over your calculator, if you